Imagine a massive winter storm hits this centuries-old Swiss village. The grid goes down, and every historic stone house along the valley goes completely dark.
Right, just freezing cold.
Exactly, completely dark and freezing, except for one house. And the only reason this one single house has power, heat, and lights is because it's secretly drawing energy from an unmarked white delivery van parked out in the driveway.
Which sounds completely wild, but it's actually happening.
It sounds like a movie. But today, for you listening, we're doing a deep dive into something that is going to fundamentally change how you view the four walls around you. We're exploring what's called the smart living ecosystem.
Yeah, and it really is a total perspective shift. I mean, we are so conditioned to view our homes as these static objects. A house is a box with a roof. It has a very clear property line. And the infrastructure inside just kind of sits there, passively depreciating.
Right. Traditionally, a house is a massive cost center. You pay to heat it, you pay to cool it, you pay to fix the roof.
Constant maintenance.
Always. But the researchers and engineers behind this new ecosystem, they are deconstructing that entire model. They are literally turning the house into an active, profit-generating node.
Which is a huge leap from where we are now.
It is. And to understand exactly how they're doing this, we are diving into a stack of freshly updated technical reports from the Agile Innovation Process, or AIP, dated May 2026. Plus, we're looking at some really fascinating field notes curated by Professor Mikhail Piano regarding a groundbreaking real-world test laboratory.
And, what's crucial to understand right up front here is that when we talk about a smart home in this specific context, we aren't talking about, like, consumer gadgets.
Right, not just a fancy thermostat.
Exactly. We aren't talking about putting a Wi-Fi chip in your refrigerator or installing a doorbell camera.
Yeah.
This is about the total structural integration of architecture, clean energy generation, electric mobility, and new economic models like micro-hospitality.
Which sounds incredibly futuristic. I mean, when I first hear about a fully integrated smart property, my mind immediately jumps to some ultra-modern billionaire's glass box perched on a cliff in Malibu.
Oh, sure, the Tony Stark house.
Yes, the Tony Stark house. But the team behind this didn't build a theoretical glass box. They chose the Bioggio pilot project in Canton Ticino, Switzerland. And the setting is an 18th century two-story historical stone building.
Yeah, it's beautiful.
It has an antique portico, centuries-old cellars, the whole 9 yards. And honestly, this is where I hit my first mental roadblock when I was reading the sources.
How to marry the old with the new.
Yeah, right, exactly. I mean, trying to force a state-of-the-art energy grid and modern plumbing into 18th century stone, it feels like trying to install a modern smartphone operating system into a 1920s rotary phone.
That is a great way to put it.
Like one wrong drill hole, one miscalculated trench, and you compromise the structural integrity of the entire building.
Yeah.
So how are they doing this without absolutely gutting the historic architecture?
Well, that structural friction, that exact problem, is precisely why they chose this specific building. If you can make an advanced energy and mobility ecosystem work in a delicate, protected historic structure without ruining it, you prove that this model is scalable.
Scalable to almost any existing neighborhood in Europe.
Right. And to pull it off, the engineering team relied on a core architectural philosophy from the reports, which is reversibility.
Okay, reversibility. Because, I mean, the standard approach to retrofitting old European buildings is highly invasive. You smash open the masonry, you dig deep channels to bury the electrical conduits and plumbing, you plaster over it, and you just pray you don't introduce moisture issues.
And moisture is the absolute death knell for historic stone.
It just eats it away?
Yeah, old buildings need to breathe. When you aggressively trench into them and seal those channels with modern cement to hide your high-tech cables, you trap humidity inside the walls. You get mold, you get rot, and you cause severe structural trauma.
So they couldn't do that here?
No, so the engineers in Bioggio did the exact opposite. Instead of burying the technology, they deliberately exposed it.
And the visual execution of this is fascinating. Looking at the architectural diagrams in the source material, they used exposed industrial-style metallic piping to run the cables.
But it looks really good.
It does. It isn't an eyesore at all. They gave the piping this stunning copper effect, and it runs right along the antique ceilings, intentionally contrasting with the old stone. And then they terminate the runs in these sleek, dark anthracite Feller socket.
Which is a brilliant aesthetic move, really.
Yeah.
Feller is a staple of high-end Swiss electrical design.
Oh, okay.
Yeah, by using those premium minimalist fixtures alongside the copper effect piping, they elevate the exposed infrastructure from a messy construction compromise to a deliberate luxury aesthetic. It basically gives the historic building a visible industrial tech soul.
It's like the building is wearing a high-tech exoskeleton.
Mm.
But the real genius here isn't just that it looks cool, it's the protection it offers.
Because it's reversible.
Right, because every single piece of that infrastructure is exposed, it is completely reversible. If, say, 50 years from now, a new owner wants to revert the building to its original 18th century state, they just unbolt the exoskeleton, they take it all down, and there isn't a single trench, scar, or scratch on the original masonry.
Exactly. You completely preserve the asset. But that commitment to reversibility, keeping everything on the outside of the walls, it forces a massive cascading change in how the entire building actually operates.
Right.
Specifically, it completely changes their mechanical strategy for heating and cooling.
Okay, yes. This is where the blueprints really threw me for a loop, because initially the engineers had spec'd out this highly sophisticated HVAC system. We're talking top-of-the-line heat pumps connected to complex radiant ceiling panels.
A real marvel of modern thermal engineering.
Yeah. But then, if you look at the notes, they just crossed it all out. They scrapped the high-end radiant system, and what did they replace it with? Basic independent air split units. And for hot water, 2 simple 100-liter electric boilers just tucked away in a utility room. I have to admit, that feels like a massive downgrade. If we are building the ultimate smart home ecosystem, why are we pivoting to basic water heaters and air splits? It sounds like a cheap compromise.
Well, on paper, it definitely looks like a downgrade. But in practice, it represents a highly advanced design philosophy. It's the idea of less is more for the sake of true resilience.
Okay, unpack that for us.
You really have to look at the fragility of complex systems. If we connect this to the bigger picture, a radiant ceiling panel system in a historic building requires a massive interconnected web of hydraulics.
Lots of pipe.
Tons of pipes. You have water constantly circulating under pressure through complex valves, circulation pumps, and intricate logic boards.
Which means a lot of moving parts and a lot of things that can break.
Right. And remember, water is the enemy of an old building. If there is a single leak, or if one sensor in that highly complex hydraulic loop fails, the system logic board throws an error code, and the entire house basically goes into lockdown.
You have no heat.
None. And you can't just call a regular local handyman to fix it. You need a highly specialized, brand-certified technician. You might be left freezing in the dead of winter for 4 days, waiting for a part to ship from Germany or something, only to get hit with an exorbitant repair bill.
Ah, I see. So the complexity itself is a liability. By striving for peak engineering efficiency, you actually make the house incredibly fragile to everyday realities.
Precisely. So by pivoting away from complex hydraulics to simple independent air split units and direct electric boilers, the Biogeo team completely decoupled the systems.
They stripped away the single points of failure.
Exactly. If one of those 100-liter electric boilers burns out, it doesn't take down the heating for the rest of the house.
The air splits are still running.
Right. And more importantly, any standard plumber can walk in, unbolt the broken boiler, and swap in a new one for a few $100 in about 30 minutes.
Wow. Okay, it's a calculated simplification. Resilience isn't about having the most complicated machine. It's about having a system that is robust, modular, and easy to maintain over a 50-year lifespan.
And it radically lowers the long-term operational costs, which is a huge bonus.
Okay, so we have this beautifully preserved 18th century home. It's running on extremely resilient, easily repairable systems. And all of this is being powered by a massive clean energy array, primarily rooftop solar.
Yes.
But because these new simplified systems are so efficient, pumping all that summer solar energy into the house creates a new problem. During the peak of the day, the solar panels are generating way more electricity than these simple boilers and air splits actually need.
Yeah, you get a massive bottleneck.
Yeah.
In a traditional setup, you have this massive energy surplus that is essentially wasted. I mean,
Yeah.
you might sell a trickle back to the grid for pennies, but you're losing the true value of that generation.
Right.
But in the smart living ecosystem, that energy doesn't go to the grid. It flows right out the front door and directly into the driveway.
Which brings us back to the hook of this whole deep dive, the stealth van. According to Professor Piano's field notes, parked directly outside this historic stone house is a brand new Ford E-Transit electric van. But they are very specific about the configuration in the reports, that this is not a brightly colored RV covered in swooping decals.
No, not at all. It is explicitly a stealth configuration.
From the outside, it's completely invisible. It looks exactly like a standard white commercial delivery van. You would walk right past it in a historic European village and not look twice.
Which brilliantly avoids any zoning complaints or aesthetic clashes with the neighborhood, by the way.
Oh, that's smart. But the inside is a completely different story. It is a fully functional mobile room. It's equipped with an electric kitchen, air conditioning, its own secondary solar array on the roof, a smart battery storage system, and ergonomic smart working stations.
It's essentially a tiny house on wheels.
Hmm.
But the real magic isn't just that it's a nice mobile office. The magic is what it's doing while it's just parked there.
Right, because here's where it gets really interesting. A traditional combustion van sitting in a driveway is just degrading. The alternator belts dry out, the fluids go bad, the oil just sits there getting sludgy.
It's dying slowly.
Exactly. But this electric van isn't just a parked car, is it? It is seamlessly integrated into the home's energy grid. It's essentially a giant rolling power bank for the house.
That is the core of vehicle-to-home, or V2H, bidirectionality. This is a crucial pillar of the entire ecosystem. The vehicle's massive battery and the house's electrical panel are in a constant dynamic conversation, managed by a smart inverter.
Walk us through the mechanics of that conversation. How does the house actually use the van?
Okay, so during the day, while the sun is beating down on the house's rooftop solar array and creating that massive energy surplus we talked about, the house routes all that free excess power directly into the Ford e-Transit.
It just dumps it into the van.
Right. And keep in mind, EV batteries are enormous compared to the standard expensive wall batteries people buy for their basements. The van simply soaks up that massive surplus. Then the sun goes down, the solar panels stop generating.
And that's when you want to turn on your oven, run your heat pump, and take a hot shower.
Exactly. And instead of pulling expensive peak-rate electricity from the public grid, the flow reverses.
The inverter pulls the stored solar energy out of the van's battery and feeds it back into the historic building. You're running your 18th century stone house on power stored in your delivery van.
Yes. And to address the wear and tear aspect, which a lot of people worry about because the van is entirely electric, there's zero mechanical penalty for doing this.
Because the engine isn't running.
Right. There is no engine idling in the driveway. No belts, no oil, no complex combustion parts degrading from disuse. It's just electrons moving silently back and forth. The operational cost of using this massive vehicle as your primary home battery is essentially zero.
So the driveway is no longer just a slab of concrete where your depreciating asset leaks oil. It's an active, high-capacity energy hub.
Exactly.
But a fully charged van sitting in a driveway, even if it's powering the house at night, still represents a lot of untapped potential during the day. How do you monetize that setup?
That brings us to the next massive paradigm shift in the reports, moving from the technological infrastructure into the new economics of housing.
Right.
They call it Facility Management 5.0.
This is where the concept truly scales financially. Usually, facility management in residential real estate is a pure cost center. It's maintenance, condo fees, depreciation, upkeep. You are managing a static asset.
Just writing checks to keep the lights on?
Right. Facility Management 5.0 flips the asset from passive to active. You are no longer managing walls, you are managing flows. Flows of energy, flows of remote work, and flows of tourism. Because you have this hyper-efficient historic space and a surplus of energy, the property becomes an economic engine. Like, the reports mention the internal cellars can be converted into stunning wellness areas, turning the home into a site for luxury micro-hospitality.
And then you have the stealth van in the driveway.
Right. If you aren't using the van to travel, it doesn't just sit there acting only as a battery. Because it has that smart working station and kitchen inside, and because it looks so discreet from the outside, you can rent the van out right there in your driveway to digital nomads.
It's genius. The reports refer to this as slow tourism.
Imagine renting out your stealth van on a short-term basis as a mobile office with a lake view entirely powered by the roof of your house. You are stacking functions.
It's an incredible utilization of assets. The vehicle is transportation, it's grid-level energy storage, and it's a revenue-generating micro-annex. The building is a home, a power plant, and a boutique hotel all in one.
No. To really drive home how urgent it is for developers and real estate businesses to understand this shift, Professor Piano uses a historical analogy in the AIP reports that is just brilliant. He uses a World War I analogy to explain modern real estate development.
Yeah, Caporetto versus the Piave.
Right. I'm looking at this in the source material, and I'm trying to figure out how building a regular suburban house maps to a catastrophic World War I massacre. Are they saying developers are literally going to go bankrupt if they don't adapt to this ecosystem?
That is exactly what the analogy is highlighting. In the reports, Professor Piano looks at General Cadorna's leadership during World War I. Cadorna was infamous for his rigid, obsolete trench warfare tactics.
He wouldn't adapt.
No, he refused to adapt to the new, mobile realities of warfare, and his inflexibility led directly to the catastrophic defeat of the Italian army at the Battle of Caporetto.
It was a total slaughter because he wouldn't change his strategy.
Right, and Piana argues that the modern real estate industry is having its own Caporetto moment right now. Developers who stubbornly cling to the old static model of housing, treating homes as passive, isolated boxes dependent on fossil fuels and vulnerable complex systems, they are marching straight into a corporate slaughter.
Because the landscape has completely changed.
Exactly. They are being squeezed by changing climate regulations, massive supply chain material shortages, and shifting consumer demands for remote work and resilience. If they fight a 20th century war in a 21st century market, they will fail.
The rigidity is the vulnerability. So what is the alternative? How do they survive this?
The alternative is the Piave Line. Historically, after the disaster of Caporetto, the Army retreated to the Piave River. They completely reorganized, embraced rapid adaptation and mobile defense, and that fundamental shift in strategy eventually led to victory.
So in the context of this smart living ecosystem, what does the Piave Line look like?
It represents agile innovation. It means developers must embrace field experimentation, remain highly flexible, and adopt these integrated multifunctional models like the reversibility we talked about, the decoupled resilient tech, and the vehicle-to-home infrastructure.
And the broader market is already rewarding the Piave strategy. The reports make a huge point about scalability and funding. This isn't just a niche project for billionaires. It perfectly aligns with ESG, environmental, social, and governance criteria.
Which is the golden ticket for institutional investment right now.
Exactly. Because this ecosystem hits zero emission targets, utilizes existing historic structures instead of tearing them down, and promotes a circular energy economy, it is actively targeted by major European funding programs. Europe is basically throwing money at projects that can prove this works.
And that's why you see major research hubs, like SUPSI in Switzerland, partnering directly with technology manufacturers right there on the ground in Biogia.
They aren't just writing papers about it.
No, they are bypassing the theoretical stage. They aren't just talking at academic conferences. They are getting their hands dirty, validating the inverter tech, the aesthetic reversibility, and the thermal decoupling in a real-world 18th century environment.
It proves the technology isn't science fiction. It is market-ready right now.
Exactly. It's happening today.
Okay, let's take a step back and quickly recap the major takeaways from this deep dive for you listening. We started by looking at how to bring a historic building into the future without destroying its soul, using reversible, exposed industrial design like those copper effect pipes and Feller sockets that protect the masonry from structural trauma.
Then we explored how true mechanical resilience often requires stepping back from hyper-complex hydraulics. Choosing simplified, accessible technology like decoupled air splits and standard electric boilers eliminates those catastrophic single points of failure and makes the home infinitely easier to maintain.
Then we looked out into the driveway and saw how a stealth EV van can act as a bidirectional battery, soaking up the summer solar surplus and quietly powering your house at night, all with zero mechanical engine wear. And finally, we saw how all of this integrated tech fundamentally shifts the concept of a home from a depreciating cost center into a profit-generating node through Facility Management 5.0, turning your garden and your van into micro-hospitality assets.
Which, it leaves us with a rather profound realization. When you absorb all these different threads from the reports, it raises a question that isn't explicitly answered to the technical specs, but lingers just beneath the surface of all these innovations.
Oh, I love these kinds of questions. What's the hidden implication here?
Well, if your vehicle becomes your office, your home's primary battery, and a source of tourist income, and if your historic property is constantly connecting and disconnecting temporary digital nomads in micro-annexes while pushing and pulling energy, what actually happens to the traditional concept of a permanent address?
Wow.
Right. When the boundaries of your home become this fluid, this mobile, and this deeply integrated with the outside world, the strict legal and psychological definitions of property lines and residence might become completely obsolete. What does it actually mean to be home in an ecosystem that is continuously shifting, generating, and moving?
That is a brilliant point to chew on. Is your home the 18th century stone walls, the rolling power bank in the driveway, or the invisible flow of energy and capital moving between them? We want to thank you so much for joining us on this deep dive. Hopefully, the next time you pull into your driveway or look up at your ceiling, you'll see those familiar spaces through an entirely new lens. Until next time.